Let's look at phase dimming and the output of dimming drivers. A phase control dimmer is not a control in the stricter sense of the word. These devices remove a portion of the AC signal passing through them once per half cycle. In this way, the device limits power to the load. The AC signal can either be clipped from its forward side or its trailing edge. Because drivers can tend to malfunction when overall power is restricted to them, ballast and drivers have been developed with a line which stays energized throughout the ballast's dimming range. This supplies sufficient power to the ballast for proper operation. Apparently, 3-wire phase dimming controlled LED dimming drivers also exist. For a typical step dimming ballast, applying power to one or the other of the two hot supply wires will bring the ballast's lamps up to approximately 50%. Applying power to the two hot supply wires at the same time will bring the ballast up to approximately 100%. The output of an LED driver might be a continuously controlled current source. Each LED assembly will typically be connected to a separate driver output, or the LED assemblies are connected in series and probably come matched to the driver. For a continuously controlled voltage output driver, the LED loads are connected in parallel. A popular scheme for controlling LED light output is pulse width modulation. The controller can vary full voltage, LEDs on full. The controller can apply 0 volts, LEDs off. More importantly, the controller can be switched between two levels, applying pulses to the LEDs. This varies the light output of the LEDs. Popular pulse frequencies include 400 and 1000 pulses per second. Now this is important because this is a very common type of driver. It's very energy efficient driver, and you just need to think, let's assume that these are 12 volt LED assemblies. They're connected in parallel. If we're at full voltage from here to here plus 12 volts from here to here, these will be on full. If we're at 0 volts from here to here, then of course these will be completely out. But suppose 1,000 times a second we turn them on and off so that they are on 50% of the time and off 50% of the time. You can see that in reality only half the light that you would get if they were on full all the time will come out. Now this occurs so rapidly that you should not be able to sense it by looking, and this is called pulse width modulation because if you narrow the on time of the pulses, these will be effectively dimmer because they're off more of the time, and if you widen these pulses, these will be effectively brighter because they will be on for more time. And that is pulse width modulation.